He worked mainly on palladium and hydrogen. So he's actually been one of the people that's replicated some of the cold fusion experiments and taken them further. He did postdoctorate work in Montreal with an ethanol fuel cell, and that was catalytic work, which is vital to the cold fusion process. Catalysis, we have to figure out ways to calculate that. 2 years ago, he established his own company in Berlin, and now he's trying to finish the fundamental research on cold fusion. The talk is called Philosophy of Cold Fusion. That's a word we don't hear enough lately, but it's actually an important component of anything that eventually gets produced, is what is the philosophy? And here's Jan and Marwan.
Thank you. Okay, so yes, I'm kind of a little expert in cold fusion, and I'm trying today in this presentation trying to explain a quite different philosophy. That's a cold fusion philosophy, trying to explain what cold fusion is, what it means to be, and how we can get it to a practical use. So you will see that this is a quite different philosophy I'm presenting today, because normally we are mostly proceeded from the assumption that cold fusion is a deuterium fusion during long-term electrolyzers. Well, that's all fine, and that's what we can do. But you will see I have a different view. I try to make this in a broader angle, to put this in a broader angle. So I'm presenting a kind of philosophical approach to cold fusion, and so I consider cold fusion as the materialization and dematerialization process. Maybe it's one of the alternative energy sources in the future. We will discuss a quite strange fundament and axioms. We need to set up some new axioms to handle with this cold fusion, with this Coulomb barrier potential, with the nuclear forces, which makes it so difficult to understand this process. And yes, the role of water is very much significant also in terms of cold fusion, palladium, hydrogen, electrochemistry. There's I briefly outlined something. This is not the main talk, palladium, hydrogen, chemistry. And yes, so according to this model I'm presenting here, what do we have to expect in the nearest future? So? Okay, thank you. It suits, water to cold fusion. That suits. Right. Okay. Yeah. So what's our present situation like? In short, in brief words, from the environmental viewpoint, we know we're heading towards the dead end this century. There's a global warming. We all enjoy this process of global warming, no? Okay, but at least, there are millions of tons of greenhouse emission on every day. I extracted a figure from literature I read. It's 100 million tons greenhouse emission on every day. It's tremendous. I couldn't believe this, but then reading other sources, other kind of literatures, and extracting the information, it's roughly the same figure, 100 million tons greenhouse emission toxic gases on every day released on air. So we know that will lead to a global warming. We know from the economic viewpoint that we strongly depend on, okay, right. We strongly depend on cold fusion, sorry, not now, later, but we strongly depend on fossil fuels, oil, coal, and gas. At least we have the impression that we are dependent on fossil fuels, actually. Right, so, but we all know the prices for fossil fuels rise up, and in 20, 30 years, there won't be any more. We run out of this, of oil, and so we have to have a replacement. So what are our options like? Solar energy, I'm personally a strong fan. I'm a fan of solar energy. I'm far away from being an expert, but I think this is one of the options in the future. But we know that's not enough. Wind power, it's fine. Batteries, fuel cells, okay. Fuel cells. I've been working on fuel cells in Montreal. A catalyst fuel cell, ethanol fuel cell. But mainly my impression is I don't believe in fuel cell. I don't think the fuel cell will be a part of our future. The simple reason is, well, let's take the hydrogen fuel cell. There are three main problems. The one problem is the hydrogen fuel cell, you have to generate the hydrogen somehow, and that costs energy. Second main problem is you have to handle this hydrogen. And, well, how to do this? I mean, hydrogen filled in the tube, the tube is very heavy. So running a car on hydrogen is not going to be very useful using this tube. Therefore, there's a strong division in electrochemistry, physical chemistry, which is called hydrogen storage materials. They're dealing with this project. They're trying to come to a solution, but so far there aren't any significant results on this. But the third main problem is, and that's, I think, the strongest one to disapprove this hydrogen fuel cell is, you know, any fuel cell is running, you need a catalyst for a fuel cell. And the catalyst mainly contains a noble metal. And this noble metal is not cheaply available. So if you consider the development of price within the last 10 years, the price for a noble metal, gold, platinum, palladium, rhodium, almost doubled. So what do we have to expect in 10, 20 years? Running a fuel cell on running a car on a fuel cell, whatever, running the economy of fuel cells with a catalyst which mainly contains noble metal, you can't deny it. There has to be a noble metal there. I see there, you know what I see? I see from a commercial aspect, I see there a problem. Of course, you can reduce the quantity of platinum within a catalyst and an alloy. Yeah, you construct an alloy. So then the quantity of your noble metal is less than 50%, or you can fabricate a nanostructured material, but at least you end up with a noble metal, and that's very, very expensive in 10, 20 years. So conclusion, I don't believe in fuel cells. So nuclear power, fine, that's fine, yes. According to the conventional science, it means so hot fusion, hot fusion study, investigation, and they always keep telling us maybe in 50 years that's then practical, right, it's fine. And the other thought is then the fission, so uranium or plutonium fission. That's also fine, but at least there is, if that's not working very well, if there's some insecurity, then we are really in problem. So we need some replacements. Again, I favor very much the solar energy, wind power, batteries, yes, but it's not enough. It won't be enough. So, okay, what about cold fusion? You may remember the memorial Pons-Fleischmann experiments in 1989. Was here in Salt Lake City, where, yes, they carried out, Pons-Fleischmann, they carried out a long-term electrolysis in the experiment, a long-term electrolysis in a heavy water solution, so deuterium-containing solution, and with the use of palladium, plain palladium used as an electrode. So now you have to know that palladium has got the ability to absorb large quantities of hydrogen, deuterium, into the palladium bulk. That's a unique metal. You will find it. You will not find it in the periodic system. You will not find it somewhere else. That only contributes to palladium. So, okay, you have a large quantity of hydrogen, deuterium absorbed into the palladium bulk, and the idea of Martin Fleischmann 1989 was, so with the penetration of deuterium into the palladium bulk, it's likely that deuterium occupies interstitial sites within the palladium bulk, tetrahedral or octahedral, whatever, whether it's alpha, beta hydride phase. So, and the idea was, yeah, the distance then between these nuclei become closer, obviously. And so the collision between deuterium becomes much more enhanced. Well, that was the idea, and you may remember this experiment or the press release. There was a unique output, a tremendous output, tremendous output, and Martin Fleischmann could only attribute this output to a nuclear fusion reaction, because comparing input-output, the output was so tremendous. It was, in his his conclusion was it is a nuclear fusion reaction at room temperature in an electrochemical cell. This experiment has found to be, well, lately, but the years afterwards, it wasn't very much reproducible. We all know this, but clearly, well, it has dropped down, and maybe it was a political issue, but I don't care so much about this. There is plenty of evidence now. The research over the last 18 years revealed plenty of evidence for this cold fusion phenomenon, excess heat, change of nuclear transmutation, and change of surface morphology in carrying out a long-term electrolysis. That means over hours, over days. And this is a clear indication for a fusion process. And the point is that's not only restricted to palladium as we recently thought. This also occurs when nickel or gold or some kind of other elements are used as the electrode on which then the electrolysis appears. And also, what's also interesting was that it does not only occur in a heavy water solution, so in the deuterium-containing solution, it also occurred in a light water solution, so in just sulfuric acid solution. Of course, not with that efficiency, but at least there was some evidence given. And that's collected, that's in the Journal of New Energy, Fusion Information Center, Salt Lake City. That's occurring up there. During the 90s, the editor is Hal Fox, whatever in condition he is nowadays. We have to appreciate his work during the 90s, collecting all this information, giving plenty of evidence for cold fusion. You will never find in any other journal which collected this kind of information, plenty of evidence given for cold fusion. You will never find a scientific journal. You will never find a scientific journal. Yes, that's the only one. So I'm very glad to having read this. Right. Oh, it's. Could you go backwards? One slide backwards, please. I cannot get along. One slide backwards. Yeah, I'm sorry for this. I cannot get along. So no, backwards. One slide. Yes, fine. Yeah. So it just occurred to me, and was very happy that I was the organizer this year of the new energy technology symposium on low energy nuclear reactions, so that means cold fusion, at the American Chemical Society in spring, at the spring meeting 2007 in Chicago. So was very surprising, and if you consider that the American Chemical Society is one of the biggest societies we got, with 160,000 members, and attending this meeting, well, about 10,000 people, scientists, go to the national meeting twice a year. So, and we could set up there a cold fusion symposium, and making cold fusion somehow popular. It was really an event. We were very proud of this. Cold fusion scientist, let's say Steve Crivet, he's a scientific journalist, editor of the New Energy Times. He gave an overview. Dr. Melvin Miles, he accompanied Fleischmann during the 90s. He is a specialist in thermodynamics calculations. George Miley gave, somehow a theoretical model, and Dr. Boston Mosier, he's from San Diego's Power System Naval Research Laboratory, and they give clear evidence of cold fusion, experimental evidence, CR39 track. I don't want to talk about this. I don't have the right. I think it's not my results. So they should do this. It's a tremendous work they've been given. We're working now on the book, Low Energy Nuclear Reactions. The print is February 1st, 2008. It's in preparation, and that's released with the American Chemical Society Press and the Oxford University Press on cold fusion. If that's working out within the next 6 months or 12 months, so we were home and dry, and it's really a big issue. So this only. Okay, I have to press the, okay, right. So that's an electrochemical cell taken from my picture. It's, the design is based on my work in Southampton during my PhD. It's quite common design. That's a three-compartment electrochemical cell, the working electrode, mainly a gold substrate on which palladium is deposited, counter electrode and reference electrode. And that's what could be a deuterium-containing solution or a light water solution, 1 molar sulfuric acid. Why I'm showing you this? It's you can do with this a simple electrolysis for a couple of hours or a couple of days. It's very simple, and what you get there is lacking of reproducibility, that's for sure. But you get somehow an evidence for nuclear transmutation in excess heat and change of surface morphology just using electrolysis, simple electrochemical cell. And that's what you can get in several laboratories, Japan, USA, Italy, Germany. So there is something going on cold fusion. It's not an illusion, it's something real, a cold fusion phenomenon. There's a strong experimental evidence for this. Again, I always emphasize there's a lack of reproducibility. But at least once we note, observe in our experiments, okay, there is something going on, like a transmutation, a fusion reaction at room temperature. Even it's lacking of reproducibility. We have to look in this. We have to look to this. We have to look into detail. That's what academic science hasn't done so far. So this experimental evidence is knocking on our door permanently. It's knocking. It's just it's challenging us. But somehow we can't imagine how a cold fusion reaction at room temperature is possible. We cannot imagine this. Why? Because of the Coulomb barrier potential. Coulomb barrier potential and nuclear forces. So that implies a high activation barrier potential between nuclei. And by the hot fusion, nuclear physics, they claim this fusion process at room temperature cannot exist. It's only possible at millions, or let's say, millions degrees of Celsius. Okay, fine. So somehow, if we can't get along with our theory, which doesn't explain the cold fusion and which ignores the cold fusion, but on the other hand, we got the strong experimental evidence, then somehow I have to wonder, maybe to question the physics, to question our philosophy, our current philosophy, and to re-evaluate our scientific understanding, our scientific view. And then I end up with the question, what's the real world like? If so far the hot fusion nuclear physics kept telling us that this fusion process is only possible at a high temperature. So what's the real world like? So there's a strong need to re-evaluate our scientific view, and probably this will lead us to a new science. It's about changing the perspective. And this is really something very essential, changing the perspective, also regarding the upcoming climate change this century. Right, I think what's necessary is to establish a fundament, even if it's quite strange and different. But we need to set up a basic fundament, new axioms and new axiomatic from which then we can proceed and build up our construction to explain cold fusion and to make this reproducible. But somehow we have to start with a new fundament, with a new way of thinking. And then, always this fundament having in mind as a basis, we build up this new way of thinking, and we keep logical within this frame. Of course, not logical to the conventional science, that's for sure, that's not logic. It's another kind of way of thinking. So, axioms, somehow, I have to get along with this. So, yes, again, this cold fusion phenomenon, to understand this, it's clear we have to face that the Coulomb barrier potential does not exist somehow, or at least it exists, but we have to circumvent this problem. So, with this axiomatic, I declare cold fusion as an interaction between matter and antimatter. And so my first axiom is, that I distinguish 3 different states. Our whole universe, our whole being, I distinguish 3 different states: the 0-point state, the antimatter state, and the matter state. So, I mean, it could be all rubbish I'm talking, yes? But at least with the philosophy or with the physics, right now, we cannot explain cold fusion. So we have to change something. And we have to begin with a new axiomatic. And that's what I'm doing here. So cold fusion is an interaction between matter and antimatter. Then antimatter. Yeah, okay, with an antimatter I could circumvent this problem with the Coulomb barrier potential, but somehow antimatter. So far, the physics believe to find the antimatter light years away from here, light years away. Well, then I just wonder myself, okay, it's just a postulation, a kind of postulation. So I changed this postulation, and I say antimatter is right here. And antimatter is the specific movement any particle, any material particle is surrounded with. So I'm as a material particle, I'm confronted wherever I am, here on Earth or light years away, I'm confronted with my antimatter state. And that's the specific movement. That's a specific movement. Everything is moving in the universe. It's always about movement, moving. So, okay. Right. Yes, so I consider matter and antimatter as a coil, similarly Wating's current. We come back to this later. And antimatter must be in time advanced to matter. There's no other way. Yes?
I think it's the button on the left there.
The left.
This one.
Okay.
Yeah.
Right.
It's this part of the button. Every so often you get it.
Well, yes. Well, it will take me some presentations to get to know this. Okay, so the 0-point state divides, now, okay, in our axiomatic we distinguish 3 different states: 0-point state, matter state, and antimatter state. And now, the 0-point state divides into matter and antimatter state. Now, if there were matter and antimatter in time equal, then they would collapse instantaneously and they wouldn't exist. So we had to set up in our axioms that antimatter is in time advanced to matter. And this time difference, this allows then the existence of matter and antimatter. Right, we proceed from the circuit of energy. That's the basis of this philosophy I'm presenting. Again, it might be rubbish I'm talking, but somehow I need to approach this phenomenon and I need to give maybe a plausible explanation. So I emphasize this circuit of energy, and I say that energy is just around. It's always surrounding us. It's there. It's everywhere. And there's a and it's just a circulation. 0-point state, 0-point energy transforms in antimaterial energy, and the antimaterial energy in material energy, and back to 0-point state. We come back to this later, but that's the basis of everything. We do not need to search for energy or to look for energy. The energy is just there. It's just there. Yeah, right. Okay, what I'm claiming is a kind of new way of thinking. Let's say we have a problem, a dysfunction or body dysfunction or problem in our laboratory or whatever. We are, with the illusion, we're lacking of something. We always have in mind, are we missing something? We deeply investigate our problem, searching for the solution and searching for that what we're missing. But we aren't missing anything. So, but what happens is that our investigation is branching. So there's a wide range of different branches, specialization. And then somehow, if we go deeper and deeper, caught in some kind of a labyrinth, we have the feeling we are completely lost in a jungle. So in other words, you see, I'm a trained PhD scientist in electrochemistry. Electrochemistry is a part of physical chemistry. Electrochemistry itself divides into several uncountable issues, divisions, whatever. Attending electrochemistry conference, you have to, well, maybe there are 3,000 people attending this with you, and everybody is talking about his specialized issue. And you sit there, you sit leaning backwards, and you think, what is he talking about, and where is he going with this? And so, yes, somehow, I mean, I do not want to blame anyone in the academic science, but somehow I have the feeling that academic science is only an occupational therapy. So it's just yes, it's really my feeling. I was very much disappointed to find this out, you know. I mean, I had to be honest to myself, so I need to come to a decision to step out of this and to make my own, because I have a responsibility to myself, giving my life a meaningful sense, and not just only being occupied. You know, science, academic science is only about being occupied. You circle around the truth. It's not about finding a problem, it's about investigating. And the good thing is you publish papers, and you publish papers, and you publish papers. Okay, that's fine. Yeah, so it's, my impression is it's only a therapy. So in other words, if you need some therapy, don't go to the psychiatrist, just do academic science. It's the best. Well, it's somehow the best therapy you could get, believe me. It keeps you busy all the time, 24 hours, and it's a never-ending story. It's a never-ending story. You don't get to the solution. So, well, what on the other hand is then, I'm trying to reverse now my thinking and changing the perspective. And what is if we are not lacking of anything, that everything is just in access to us, it's just here in front of our nose. But with closed eyes, I cannot see this, it's clear. I need to open my eyes, and then once I open my eyes and I change the perspective, probably 180 degrees in the opposite direction of the initial one, you know, 180 degrees, I change my perspective, and then I'll be able to open the door, and I can see the world very much different from the initial one. And then the solution is there, and functioning, and then I'm near the truth. But for sure, I won't get to the truth circling around the nuclear, and it never ends, and then I wonder myself, really. So the left one here, okay. Right. So this is, again, it's a kind of philosophical approach to this confusion phenomenon. In principle, it requires a deep thought through mathematics. I'm not able to present now this mathematics. Maybe I'm able to do this in 3 years. For now, we have to get along with those sketches I draw there, and with the words I'm saying. So let's say maybe this is a kind of an atomic model. Okay, it's just my bloody thinking. Might not be real. So again, I consider 3 different states: the 0-point state, the antimatter state, the matter state. And I don't care about the microscopic or macroscopic world. There's no difference for me. I consider every being, in every sort of being, in every universe, I consider these 3 states. So at 0-point state now, there's antimatter and matter. Of course, they are symmetrical. There's no difference. Yes. So therefore, in principle, they wouldn't exist. They would collapse instantaneously. So if we were at 0 point, we wouldn't exist. We weren't here. So we have to allow the antimatter in time advance to matter, and that appears, according to my philosophy, just in a way like, you know, 0-point energy is always there. We remember the circuit of energy I presented beforehand. So there's only a circulation of energy. And we have to understand this circulation. We interrupted this circuit. That's a problem. And with our purely materialistic viewpoint, we interrupted the circuit. So we just proceed from the 0-point energy. 0-point energy pushes the antimaterial state 1 quantum state ahead to the material particle. Now, there's now a transformation from antimatter to matter to the material state. It's a kind of a frozen movement. We come back to this later. So now an interaction, let's say I'm a material particle. I'm confronted with my antimatter, with the movement, with the specific movement. We set up the basics in the axiomatic beforehand. So now in interaction with my antimaterial particle, I get this materialized energy out of myself transform it into zero-point energy, and appear at the next quantum state as antimatter again. So in principle, there's no difference in myself between matter and antimatter, just where you stand and what kind of direction you are in. So zero-point energy transforms into antimatter, and of course, this results in an asymmetry between matter and antimatter. And the more zero-point energy is pushing the antimatter one quantum state and another quantum state ahead, the more the asymmetry is there enhanced, and that's the energetic imbalance. The energetic imbalance, I call this energetic imbalance. There are two ways. A building up energetic imbalance is an element building up reaction. That's one direction. And the other one would be the element consuming reaction. That goes reverse. And of course, we need to consider the time. There are then two directions of time. So this is the materialization process, element building up reaction. The energetic imbalance is increasing. So now if I take this model and this kind of approach, I think about the universe. Well, as a little human being, you know, I'm thinking about the macroscopic world and about the universe. And my first question is, does this endless discussion about the Big Bang helps us to clarify how the universe works? So to clarify the mechanism. Well, if you, again, academic science, how it works. There's plenty of literature given in the library, you know, such a bunch of literature and about the Big Bang and the academic science is now to clarify or to investigate this materialization process with the Big Bang is now in a frame of a fraction of a fraction of a fraction of a fraction of a nanosecond. Yes? So they're trying, and within this frame, they're trying to explain the Big Bang and the materialization process. Well, my question now is, does this help us? There's one big question I got in my mind. Where does this energy for this Big Bang comes from? Where is the energy originated? And the only conclusion I come up with, according to the philosophy I'm presenting, is matter-antimatter state. There are two directions. The one is the expansion. Matter-antimatter gets much more asymmetrical. Energetic imbalance builds up. And the other way is the contraction. So that's the energetic imbalance depletes. It's an element consuming reaction. Matter and antimatter gets much more symmetrical until the universe is not anymore and expands again. So these are two directions. And there I've got two directions of time. The one is time is negative, energetic imbalance increases, and the time is positive, it depletes. So there are two directions, and we will see explaining this cold fusion phenomenon in the way I see it. Again, it might be rubbish I'm talking about, but in the way I see it, we have to consider two directions. Right. Yeah, okay, that's the energetic imbalance. That's the antimatter. Well, we got now one direction of time, the negative ones, the negative direction. Antimatter materializes spontaneously, instantaneously into the matter, material particle. The time difference between antimatter and matter, that's the energetic imbalance. It goes up, it rises up, the more the antimatter is in time advance to matter. And that's the expansion. I can reverse time, and then the energetic imbalance depletes, and I have a dematerialization process. So, right. Now, what about matter and mass? Cold fusion. If you're dealing with a fusion process, of course, you have to think about matter and mass. What is matter and mass? Now, we remember this equation. Okay. Right. How I see it is, matter is a frozen movement. Mass is a frozen movement as a reflection of the outside world. So, let's say I'm now a material particle. Yes? And I only proceed from that what I said beforehand, just at the beginning in the axiomatic. That's all what I'm doing. I just derive my logical way of thinking based on a setup I presented you beforehand. So let's say antimatter, I'm a material particle now. I'm confronted with my antimatter. That's, according to the setup, that's my specific movement. So I'm surrounded by movement. Everything is about movement. Right. Now, This is now my antimatter, and this energy materializes into myself as a material particle, so matter mass is nothing else than a frozen movement. I need to get this now transformed, converted into a movement again. So, according to this model, somehow I come up with the conclusion that the Earth is expanding. I don't have any proof for this, but I remember Dr. Miles' talk yesterday. So who knows? But that's the conclusion I only can come up with. Right, cold fusion, how I see it, is there are two directions of cold fusion: materialization and dematerialization process. To my mind and to my current experience, cold fusion is a physical chemical reaction so far out of our conscious. There are two ways, two directions. The one is the materialization process. The other one, the dematerialization. Materialization is an element building up reaction. Dematerialization, element consuming reaction. There are two ways. 0-point energy transforms automatically into antimatter, pushes the antimatter one quantum state ahead, and this materializes automatically, so the matter, the mass, is increasing, but it's just only a frozen movement. So I need to get this dematerialized, so I convert this frozen movement into movement. That's my dematerialization process. Right. Yes, so that's about the circuit of energy. Again, what about the 0-point energy? I very much assume that all members here of the audience believes in 0-point energy. Otherwise, you wouldn't be here. Unless there's a CIA agent observing us, spying on us. But okay. So the 0-point energy is, again, according to the basics I set up just at the beginning, the energy is just there. It's surrounding us, it's in us. And the 0-point energy, maybe we do not need any device to trap the energy. Maybe it's already there. It transforms into matter just automatically, instantaneously. And probably if we take this philosophy or this way of thinking as granted, or having this in mind, maybe we can explain our diseases. Any disease is, to this philosophy, due to an excess of energy. It's hard to believe. I can say it 100 times. Nobody believes me, and that's okay. But I just finished writing a book. It's my second book. It's just now only in the German language, and that's translating the title into English. It would mean "Disease as an Exit of Energy: The Secret Knowledge." So by the end of this year, or year and a half year time, probably we'll finish the translation into English, in case somebody's interested. Well, the energy is just there. It's surrounding us. It's in us. And I don't think there is so much need to construct anything to trap or to catch the 0-point energy. To my experience, to my mind, it's already there. It's just there. It materializes automatically in antimatter. Antimatter, again, we consider the three different states. 0-point state, antimatter state, matter state. So 0-point energy pushes the antimatter one quantum state ahead. And now this energy materializes, transforms, and my material particle, surrounded by its antimatter as a specific movement, now is in mass increasing, and it's only a reflection of the outside movement. It's a frozen movement. So now I get this material particle. Let's say now I'm a material particle, and I need to transform, to convert this frozen movement into movement again. So I jump one quantum state ahead. And with this jump, I dematerialize my energy from material to 0-point energy and quantum state ahead. And then I appear to be as antimatter in interaction with my next material particle. And that's the whole circuit. You can see it in a microscopic way or in a macroscopic sense, whatever, to explain maybe the mechanism how the universe works, or to explain how this, these little kinds of elements and protons and electrons and quarks and whatsoever, how that works. I mean, that's fine. We can do this. So, again, this is how I see it. That's just a circulation of energy. So, and derived from this circulation, I presume, or I postulate, cold fusion as a physical-chemical reaction consisting of two directions, the materialization process and the dematerialization process. And what we have to only consider is the dematerialization process, because we want to generate energy, an alternative energy. So, but then, there's one aspect I want to point out, the climate change. So, according to the model I'm presenting, that the energy is right there. The antimatter is right there. It's our specific movement. Yeah, we're heading in a kind of a dead end this century, or in 200 years, I don't know. So there is what we did the last 150 years is we combusted fossil fuels, oil, coal, gas, from a dense matter and converted this into a free movement that's just in front of us, a free movement. And we always we think that this is so much necessary, we are so much dependent on oil, and we never thought about that this movement, this antimatter is just our energy, yes? So what we're doing finally is, we're heading towards this dead end, and again, it's a real figure, 100 million tons greenhouse emission every day. It's huge, it's unbelievable, it's unbelievable. So this is my antimatter, this is my movement, this is my energy. And since we do not realize this, I think we will have to pay the tribute the next decades for that what we've done the last 150 years, the combustion of fossil fuels. So somehow we need to change our perspective. Either, I know everybody here in the audience is willing, is keen to do this. There's no doubt about this. But I'm afraid of the academic science, and so somehow we need to think reverse. We need to change our perspective. And are we heading towards this dead end? Well, right. Okay, what has this to do with cold fusion and electrolysis? I pointed out right at the beginning. You remember the setup at the beginning, that I consider matter and antimatter as a coil, similarly vortex current. So antimatter, antimatter, they're just here, just a coil, just a coil. Now with the electrolysis, I mean, we know there's strong evidence that carrying out the long-term electrolysis, you will get transmutation, excess heat, whatsoever. Now, with the electrolysis, what's happening? My explanation, again, I might be wrong, but it's just an attempt. My explanation is, in assuming or postulating matter and antimatter as a coil, similarly vortex current, I pretty much assume that the flood of electron provided with the electrolysis is also a coil. And so, there are different factors now influencing this process, but somehow matter and antimatter get symmetrical with the flow of current during the electrolysis. So remember the two, we remember with time, antimatter materializes into matter. With time, there's one direction of time. Matter and antimatter gets much more asymmetrical. Reversing now, this is the materialization process. Reversing now time, we can get matter, antimatter symmetrical so that it collapse instantaneously and with a release yielding a significant amount of energy. So to do this, obviously there must be a chance to do this using the electrolysis. With electrolysis, I provide a permanent stream of current, a flow of current. And this somehow considering all the factors determining the process, pulsing procedure, electrode modification, if it's nanostructured or not, what kind of electrode you use, design of electrochemical cell. Yeah, so you might enhance these processes so that matter-antimatter gets much more symmetrical, collapse, and so there are now a transmutation process occurs and a release of energy. So we usually think that this release of energy is an excess heat. Yes, it is an excess heat. But that's not the one energy source I'm talking about. What I think and what I somehow, but not reproducible, observed in my laboratory in Berlin is that there is an electric current opposite to the initial one, so 180 degrees opposite, and an electric current of less, or let's say no resistance, so fairly similar to a superconductive current. I can't tell you how nice it was to observe this in my laboratory, but somehow it's not reproducible. So that means there are quite different factors determining this process. So, but again, what I think will cause fusion is we can result an electric current. Excess heat, yes, that's fine. But I'm talking about this electric current, which is 180 degrees opposite to the initial one, and so it's fairly superconductive. So I could circumvent all the academic science, the work they've done, the papers they've published about superconductivity and how, how well equipped. I mean, they got a very cost-extensive equipment. I don't believe in this cost-extensive equipment. I believe in the simple thing. It's always about simplicity. The simple thing, and I think that's a better way to approach it and to solve our problems. So, right. Okay. So why it's now palladium? Coming back to the words I initially said, why palladium is so much significant for this process. We remember what I said at the beginning, that palladium has the ability to absorb hydrogen or deuterium in large quantities into the palladium bulk. So usually research scientists working on cold fusion presumed or proceeded from the assumption that that's a deuterium-deuterium fusion. Deuterium occupies interstitial sites within the palladium bulk, so the distance between two deuteriums become closer, and the collision is likely to enhance. So therefore palladium could be that could be the reason why palladium is so much significant for this cold fusion process. But according to my philosophy now, I think that's not the case. I think the kinetic issue is very much important. The kinetic aspect, it's about diffusion in the palladium bulk and diffusion out of the palladium bulk. And that's at high velocity. So that occurs rapidly, depending on the electrode modification. So let's assume that's a nanostructured palladium film with the pores running continuously through the film. Then you can imagine the kinetic issue is much more enhanced. So there's a diffusion of deuterium hydrogen into the palladium bulk and out, and that occurs very much rapidly with the use of palladium, and especially with the use of nanostructured palladium. So I don't want to go to detail now in explaining this cyclic voltammetry. It's a palladium hydrogen electrochemistry. That's part of another talk. So it's a cyclic voltammetry, current versus potential. You can see here the plain light, that's palladium, plain palladium film. The red one is a nanostructured palladium. You can see here the difference. That's the hydrogen region, that's the oxygen region. That's the hydrogen region. The hydrogen region using nanostructured palladium is well pronounced. You wouldn't get this with plain palladium. In Fleischmann in 1989, there wasn't any nanotechnology, so he only could work with plain palladium, with this one. So he couldn't have an inside view of the hydrogen region with the use of the nanostructure. And this is an adsorption peak, adsorption. So hydrogen and deuterium adsorbs on the electrode surface, and from which then occurs the diffusion, the absorption to the palladium bulk. That's the alpha, that's the beta hydride phase. But we don't want to go into detail now. So why I'm putting this now here into this talk is because to emphasize the kinetic aspect, because in carrying out electrolysis, after a couple of hours, you will see that that beta hydride phase is significantly enhanced, significantly pronounced. And that's the kinetic issue. It's about diffusion of hydrogen deuterium into the palladium bulk and out. And now we come back to the fundamentals, basics I set up right at the beginning, that I consider matter-antimatter as a coil, similarly vortex current. So let's with the penetration of the deuterium, let's say hydrogen into the palladium bulk and in and out and in and out, and using a nanostructure, it can occur very rapidly. With the basics I set up just beforehand, thank you. With the basics I set up just beforehand, we consider this as a coil, just as a coil similarly vortex current. So matter, it's just only a coil, nothing more than a coil. And that would make our explanation easier, at least to give a plausible mechanism for this process. Because then with the electrolyzers, with a stream of current, it's also nothing else than a coil. I can make matter-antimatter symmetrical. Of course, there are many different factors influencing this process. There are many different factors influencing this process. Okay, 10 minutes. And pulsing procedure. What kind of electrode used? And the design of the electrochemical cell. It's certainly not the one I showed you. It's a quite different one. And I remember the Austrian research scientist on natural philosoph Victor Schauberger working on this. Well, he actually did a tremendous amount of work, and I extracted various information from him. I extracted this to my work. So. Right. Mm-hmm. Oh no. Can you go backwards? One slide backwards, please. So then we end up one slide backwards. I stepped. John, can you go one slide backwards, please? I stepped one. Back up. One back. Yes. Okay. So now that's yes. So with the electrolyzers, we end up then in a sort of transmutation, excessive transmutation, electrical current opposite to the initial one. We transmutate through all the quantum states, and you will see where we end up to. That's what I'm heading to. So now cold fusion, it's mainly what we're interested in is an implosion process. So far we gained our energy, the last 150 years especially, so far we generated our energy mainly from explosive reactions. And that will lead to a sort of climate change, to a catastrophe. So maybe we should think in a way that, yes, focusing on this implosion reaction, cold fusion as implosion. Right, that's now the target. What can we do with the cold fusion? What's possible in the future? How I see it. Maybe I'm wrong, but how I see it. It's an alternative energy source, for sure. It's a dematerialization process. Transmutation, transforming energy in a sort of energy I want, mechanical, electrical, whatever, and it's a sort of water purification, recycling contaminated water into clean water and generation of energy. We come back to this. And of course, if I'm able to transmutate down the elements from a higher to a lower number in carrying out electrolysis, I'm able to dematerialize the toxic waste, the disposal, the nuclear waste. So water, let's say something about water. Water is a very crucial issue in our life. We all know this. Drinking water, a few liters, makes us, gives us a good healthy conditions. So water, it's very much essential for industrial use, also in the private households. Let's give me an example. A treatment of oil of 82 million barrel oil a day, that's what we need every day. 82 million barrel oil, that's what we need every day here on this planet. Requires 400 million barrel water a day. That's then just rubbish. It's disposal, it's waste. It's contaminated water, and that's 400 million barrel water a day. Can you imagine this? Well, that's only a question of time, and then we're blown up here. So, and for the private households, yeah, you know, there's a dramatically growing population on this planet. I got nothing against this. That's fine. But we need to face this. So we need, we need to come up with some solutions. So at the year 2025, roughly we're about 8,000 million inhabitants here on this planet. Each one needs probably 2-3 liters drinkable water. On the other hand, the sea level rises up. The groundwater level declines. So we got much less drinkable water than ever before, but the growing population, and on the other hand, that's, don't forget, that's 400 million barrel water a day, just contaminated, just rubbish, disposal. So we need a water treatment, but so far it's at high cost. We think we have to put energy into our water recycling system, but according to this philosophy I'm presenting, we could generate our energy from the water. At least what we need is a new technology to recycle water at low cost, and that's urgently required. So that's, I'm nearly about to finish. This is a cyclovoltammetry again taken from my laboratory. It's tap water, comparing tap water and urine. So this urine, so you see the difference. You see the difference in energy here, energetic imbalance. Urine has got a much tremendous more significant energetic imbalance compared to tap water. So if we think that we need, let me point out this, we always think we have to drink energetic water or somehow to get energy in our body, drinking water, and that has to be special, that's very much specialized. So let's say water is nothing more that carries away the energy out of our body. Water carries away the energy of our body. Water supports the dematerialization process. So now a clever electrochemist would go there and say, okay, that's my energy, that's fine. I can generate some energy from this. So I apply here an oxidative current and generate an electric current just here at oxidative potentials. That's fine, you can do this. And you would gain a few microwatt power, that's fine. But I see it very much different. I consider the whole range, that's my whole energy. And by doing the electrolysis, I might be able to dematerialize the contamination to water, generating energy and generating drinkable water, coming back to this line, to this plot here. Right. Water is somehow supports the dematerialization process. Of course, we can consider water as a medium which makes any chemical substance soluble, and that's what we did so far at the university in academic science. Well, water, to my mind, well, that's the, I call it matter and antimatter, forget this here, matter and antimatter. So water somehow carries away the barrier between matter and antimatter. Well, let's assume Feynman and Co. in 1941 presumed the communication between material particles, electrons, and so on. So why not taking this as granted, adding this to the philosophy I'm presenting, and presume that there is an ongoing communication between matter and antimatter? But what is if there is a barrier inhibiting this communication process? So water is definitely something which carries away this barrier and makes the communication between matter and antimatter possible. And now, this now is my energetic imbalance. That's the time difference, due to the time difference. Now, if this time difference increases, my energetic imbalance increases. And let's get back to the disease. The quantum of this energetic imbalance in our body determines the intensity of any disease. of any disease. Right. Yeah, so I'm now about to finish, so that's my conclusion now. We need to change our perspective somehow. Yeah, to understand cold fusion, I consider the three different states: zero-point state, matter and antimatter state. And what we need we need a new philosophy, a new physics. We need probably an adequate atomic model. And we proceed from this circuit of energy called fusion is to my mind a materialization and dematerialization process. Yes, what we can do with cold fusion is probably water purification at low cost, or maybe generating energy from the contamination as an alternative energy source, and we maybe probably can rid of the toxic disposal anyway. So water plays a significant role, that's for sure. Of course, what I'm saying here, I mean, it's quite nice, you know, nice philosophy, and people will say, well, fine, okay, yes, good, does it work? Okay, it's a lack of reproducibility, of course. But I want to say honestly, with this project, I'm busy for the next 100 years. And what I'm doing now, and what I'm trying to, to address people is, yeah, we need to change our perspective. We need to come to a new way of science, creating a new science, creating a new fundament. And from this fundament, then, we build our construction in any way we want. We keep logical thinking. But this, of course, requires plenty of years of research. Well, when we want to start? In 20 years, 30 years? Maybe it's too late. You know, to finish now, my last 2-3 sentences. We are so near our new energy resource. It's nanometer. We are nanometer away from this. It's just here in front of our nose. On the other hand, we are light years away from this. If we follow up the academic science at the university, and we are light years away from this, there's no chance. So it requires one single step to gain our new alternative energy source. One single step. It's so painful, it's so tough, this single step, because we have to throw away probably all we've been trained to, all we've learned. We have to throw it away to come to a new science, to a new way of thinking, to solve our problems. Who knows, in 20, 30 years, we won't have even time to take a deep breath. It's no time anymore. Time is running out. 10 years, maybe 20 years, and then it's heading towards a dead end. Okay, we don't want to be pessimistic. I'm a person who's very optimistic. So what I'm saying is, just trying and making the best of it. Yes. So thank you. Thank you.
Ladies and gentlemen, Jan Marwan. Now, Jan will be in the foyer just outside the doors here for questions and answers. We're going to take a very, very short 7.5-minute break, unless